right, welcome to the AI Minds podcast. We are back for another episode. This is a podcast where we explore the companies of tomorrow built AI first. I'm your host, Dimitrios, and this episode is brought to you by DeepGram, the #1 voice API on the internet today, trusted by the world's top enterprises, conversational AI leaders, and startups, some of which you may have heard of, like Spotify, Twilio, NASA, and Citibank. And today I have the pleasure of getting to speak with the co-founder and CTO of Elefant AI, JJ. How you doing, man?
Oh, hey, thanks for having me.
So let's go through your colorful past before we really dive into what Elefant AI is doing and some of these difficult challenges that you're working on. Because it's fun that you were born in New Zealand, you traveled around a bunch, eventually landed in the US, working at a job that is doing robotics these days because you fell in love with machine learning in was it the PhD phase of your life?
Yeah, that's right. I did a PhD in neuroscience, and the main things I learned were I actually ended up using a lot of machine learning in that role to analyze data, and I realized I love machine learning, and I would never be a very good neuroscientist. So, uh,
So just go straight for the machine learning. And how did you end up at a robotics company?
so they were actually initially doing like spiking neural networks. So they were one of the few companies that was interested in my neuroscience background. Um, a few kind of tech and machine learning companies interested in my neuroscience background. So that's how I went there. And then over time, they sort of pivoted away from spiking to just more focused on like applied robotics.
I don't even know what spiking neural networks is, and I feel like I've heard it all. So what is it exactly?
Yeah, so I mean, so first of all, I'm pretty old, so this is kind of before deep learning took over the world. This is when machine learning courses still talked about like SVMs, and I don't know if you remember like ferns and things. And so yeah, there was this goal that you probably know, like in a deep neural network, like if you have a fully connected layer, you have like a large matrix of numbers, and like every forward pass, you've got to kind of multiply every number. And the idea of spiking neural networks is inspired by the brain, is that instead of kind of constantly outputting a value, that neurons kind of can choose when to spike, and only then do they need to communicate with each other, right? So they send like an event like I just spiked. Similar to the neurons in your brain, they don't constantly transmit like a floating point value. They send like specific events. And so there was and still is to some extent interest in trying to build both hardware and like algorithms that can mimic the brain in that way. And so that was, we were, I would say like back then, this was, oh my, like 2012 was when I joined. There was like quite a trendy thing, and there were several companies working on it. IBM was building a chip. I would say it still exists, but it's maybe less, kind of deep learning ate their lunch.
Yeah. So you saw the writing on the wall with deep learning, and you went to the mecca of deep learning and joined DeepMind right when it became Google DeepMind.
Yeah, yeah. So actually, I have an old email from because you probably know two of the founders of DeepMind also came out of neuroscience backgrounds. And so I actually have an email from when they very first started saying two of Peter Diane's postdocs are starting a company. Do you want to talk to them? And I was like, no, I just accepted this other offer. Uh, so I never did until much later. Um, so I joined there. Just yeah, they were like a really interesting place at that time. Pretty small. I was around like the 70th employee. They were, the kind of capital of like deep reinforcement learning. And yeah, doing a lot of interesting stuff. So I was pretty attracted to go there.
And what did you work on when you were there?
Yeah, so mostly like deep reinforcement learning. And I guess I was particularly focused on, well, the technical term would be like continuous action spaces. But I guess like basically kind of using deep reinforcement learning in applications such as robotics.
Okay, cool. So you had that robotics thread. And then what kind of puzzles me is your next move, and you decided to go on to work on the recommender system at Twitter, which feels like a bit of a pivot.
Yeah, so actually there is a bit of a story there. So I would say, like, first of all, I had a really good time at DeepMind, and it was just transformational. I got to learn from some like amazing people there, um, like Nicholas Hess and David Silver, who just, are really like built the foundations of the field of deep reinforcement learning. And and I learned a lot. I kind of did become a little bit frustrated towards the end, and it kind of remained true until relatively recently, I would say, is that deep reinforcement learning had been like a super successful academic field. DeepMind, for example, and OpenAI had like amazing demos of agents learning to play complicated games, and lots and lots of really cool papers. Um, but very few products or applications. Like nobody was using deep reinforcement learning, and
Yeah.
I kind of became interested in why, because that wasn't true of deep learning in general. Like deep learning is used in like all sorts of places, but deep reinforcement learning, and this is, 5 years ago now, I would say it's probably fair to say it really was not actually used in almost any product, despite being like a hugely important academic field and research area. And I kind of became interested in that and why that was. And that's part of what led me to want to look into applications of deep reinforcement learning. And then around that time, Twitter became interested in kind of using deep reinforcement learning to improve their recommendation systems. And so
Oh.
that's the connection, I would say.
Oh, interesting. And they were using is it
They were trying. It turned out it was
okay.
very hard to make it work well.
Yeah.
And so I would say, like, I joined kind of bait to work on that, but I ended up just, you know, working more generally on like recommender systems. We did some work with that. I have some papers from that time. I would say that none of them were like a huge success. Um,
So it's funny that you mentioned there wasn't much of the actual tangible applications of this technology because I when I started in ML, there was a lot of people that would talk about how at the universities, you got to learn all these cool techniques and you got to see like these hardest problems on the cleanest data, and everything was really pristine and it had an answer that you were going towards. And then you get out into industry and it's just a shit show. There's no clean data anywhere if you can even get access to the data that you're looking for and not spend like 6 months running around
right.
in circles trying to find it. And then there's no real answer. You don't know if what you've created is actually the best that you could do, or it's actually adding the business value that you're looking to add. So you're trying to like make those connections. And the idea that you're proposing is it just reminds me of how you have this disconnect of, oh wow, I want to work on this really super advanced thing, and then you go into the industry and you're like, maybe I'll just do like a random forest. Even a random forest might be a little much for this one.
Yeah, no, that's true. I think one of the things is like deep reinforcement learning for a long time, right? Like it was really successful in games, right? And games have this property that they're very cheap to run. Like, you can play many times a game. There's no cost to making mistakes, right? Like you just start the game again. Um, and, uh, and so you can use like, a very, very large amount of like experience, right? And that's why if you look at some of these games like OpenAI's Dota and some of the like DeepMind breakthroughs, they are amazing. Like I'm not knocking them, but they use like massive amounts of experience.
Yeah.
And it just turned out, I think, in many applications, uh, you know, mistakes are costly. Um,
Yeah. That's
so in
true.
a specific examples like self-driving cars, right? Like,
Mm.
people were interested in it, and it clearly is going to be important to use like reinforcement learning in self-driving cars. But unlike in a if you have a real car, you can't collect experience of like driving like a maniac on the footpath sidewalk for Americans, right? Like that's just like you're not get and so where if you're in a game, that's fine. Drive on the footpath, play Grand Theft Auto, right? It's all good. But like, and I think some of those differences between games and many applications we care about is what, made it harder. I would say that this has also changed since I joined Twitter. Obviously, the big and extremely public success of reinforcement learning now has been its use in like the later stages of like large language models, of refining them with RLHF, and then more recently just like making them smarter with like reinforcement learning. So just to be clear, I wouldn't say that it's true anymore that reinforcement learning hasn't had like big application success. I would say it was true 5 years ago.
Yeah. Yeah, no, it's like almost this, as a friend put it when he was at NeurIPS this year, everything was RL. And he was like, "What's old is new." And we're all going back to like, "Wait a minute, I feel like we've been here before."
Right, right. No, that's true.
So I could geek you out about this with you for a long time, but it feels like there is a natural thread that we can pull on when it comes to the simulation and what you're doing at Elephant AI. Can you talk to me about the inspiration behind why you wanted to go and create your own thing and why you chose this space?
Yeah, I mean, like everyone in tech, I kind of thought about starting my own company with various friends many times over the years. I think this time we just felt like there was a really open problem that you know, was not, despite all the massive amounts of investment and effort going into like large language models and visual language models and stuff, was not really being focused on. Um, and that is, making models that actually can like generate behavior in 3D spaces. And so I would also say that there is a few more people working on this. So this was like prior to like say physical intelligence and several other companies. Um, but uh, but yeah, so we really felt like, oh, there's this opening of, LLMs can do amazing things, and VLMs can even tell you about a picture and like describe things in a picture, but none of them are really giving you like what a human can do in like any 3D world. Like you can give most humans like a 3D game they've never seen before and some language instructions like, wander around and find the wizard. And they'll
Uh-huh.
basically more or less be able to carry that out without like further training. Like not perfectly, not necessarily as good as someone who's played that game a lot, but like certainly probably like make a decent first stab at it. And so that's kind of in a sense what we're trying to build is models that can generate behavior in any 3D world conditioned on language. And we just became excited that that was like an underexplored area, and that, I mean, this is part of the thesis of our company, that gaming provides a great avenue to building that foundation model, because games you can have real users, you can have them be very demanding of your model, but you can also roll things out really quickly. Like we shipped the first version of our public agent in a couple of months. And also, going back to, why was RL academically successful? It's also like much more forgiving than say robotics or self-driving cars of making mistakes initially and stuff. So, yeah, we kind of became excited both that this was an underexplored area and that gaming was a great way to like make progress in this area.
No, I've seen demos of folks using LLMs to create agents within these gaming atmospheres. And I particularly think about Minecraft. I know there's been a lot of demos of LLMs in Minecraft. And the way that I understand it is they gave LLMs tools, and the tools were inside of Minecraft. How is what you're trying to do different, and why is it something that you want to go down the path of instead of trying to just make the LLMs have better tools or work better in this environment?
Yeah, so Minecraft is a really cool project. It's really fun, and I really like. More recently, people have these kind of get using Minecraft to get different LLMs to build things for them, and like kind of giving you a visual depiction of these models, and so they're really
Yeah.
cool. I would say like one of the things is that most of the interface between kind of the LLM and Minecraft the game, like is phonetically very similar, at the level of like language. And so and there's also a great paper from NVIDIA called Voyager, which is conceptually somewhat similar. So here the LLM is outputting either like JavaScript code or like calls to JavaScript to do things. So you say like, to find resources, you can run like a function in JavaScript that's like query what resources are around, and you get like a text-based response and things. Um, and so, although that's really fun, it's quite specific to Minecraft, right? Like, so Minecraft, because it's been around for a long time, is quite an open game. People have built these APIs, so you can do things like that. Um, but most games don't have that, right? Like most games are more like you have a rendering engine and you see the world. And so, one of the motivations is that although our first agent is in Minecraft, we're trying to build underlying technology that will work across many different games without a lot of like human kind of handholding or engineering each time. And so, although Minecraft's a really cool product and really fun, if you say like wanted to get it to play, I don't know, um, some first person shooter game, I mean, it just would like it wouldn't work at all, right? It's like using the Minecraft API, right? Whereas the human who played Minecraft could get dropped into a first person shooter, and they might not be very good at shooting because you don't have that so much in Minecraft, but they'd be able to navigate around, right? Like
Yeah.
it's similar conceptually the way the world works, and so that's more the focus of what we're building.
Okay. And now, what is the benefit of having something like this? Because I see one idea in my mind is that me as a lonely gamer, I never am lonely because I have a friend to play with all the time, and it's much better than an NPC.
Yeah, so that's definitely one application. And yeah, so we're actually gonna probably like rebrand our consumer app to be called Player Two, because maybe
Nice.
it's a
Oh,
bit
nice.
clearer, like what so that use case. So I think that is one use case. I think we're still discovering others. Others could be kind of used for game testing. It's also people actually some people actually just quite like to watch them. I guess similar to how people watch like streamers, right? Like people we've had, we're sort of like I guess our company is kind of split into two pieces in a way. Like on the one hand, we're trying to build this underlying foundation model, and then on the other hand, we're trying to like experiment and see how consumers want to use it. And so
Yeah.
one application we have definitely seen is, as you said, like I want a friend to play with, and my friends are busy or something. Um, but I think other applications, some people just really want to watch it. They would just like kind of, I guess it's like your own personal live streamer or something. Um, yeah, and some people wanna play with their friends and the agent, like, just to add to the crew and things.
Yeah.
So I think we're still sort of, exploring different ways that people might wanna use it.
Man, I'll tell you what, one of my favorite things to do is play a game of FIFA with friends, and having that option to be able to do that whenever I want, because it's not really the same playing FIFA against the computer or against the NPCs, but if you have something that is a bit more human-like in nature,
Was
and it will kick it out of bounds every once in a while, and it will give you those passes when you're open, that is so cool. And the other part, I could see the streaming aspect because, streaming and watching it, just like sometimes we learn from the AI that plays chess, and we're like, "Why did it do that move?" So, but one thing that I'm thinking about what are some of the hard challenges that you're hitting as you're trying to create this foundational model that is more in a 3D space as opposed to text or vision or whatever the medium may be?
Yeah, I think it's just like the recipe's not already there. I think like, there's lots of like public recipes how to train LLMs. And although there is a lot of interesting data sets, also the data is not there. And so a lot of our work is also looking at like kind of interesting and clever ways that we can collect data. So one thing we don't have yet, but we want to make available is we already had users kind of ask is like, can I teach the agent something? And so that's one thing we're looking into is like, if our agent is making doing something dumb in one of your games, maybe you could like show us the answer, right? And that would be like really valuable training data and stuff. So I think, yeah, I would just say like it just in general, it's just like, as I said, more underexplored. So,
Mhm.
but I think a lot of it, like most of modern machine learning is not just thinking about the model or the training, but it's thinking about like, where is the data going to come from and how can we kind of build things into our product that will help get the kind of data that will help make our model better. Um, and that's again where we want to work with our end users. We do like we see that a lot of end users are actually quite keen to coach or
Yeah.
to help. And so that's an area we're working on.
You've got decentralized reinforcement learning right there,
Yeah,
which is awesome.
exactly.
Some
Yeah,
people pay good money for that.
yeah,
So
yeah.
you've got just a fan base that's interested in doing it, which is really cool. I wonder about the reward system, and what I can imagine is that if the game is being played and you either pass the level or in FIFA you score a goal, that is a really clear way to give a reward. And so do you find that from that angle, it's easier to be training these models?
Oh yeah, so that's actually quite an interesting well like sort of maybe I'll answer that a little bit indirectly if you don't mind because I think like one of the things that's quite interesting to me and I think other people are coming around to this point of view. I've had some like conversations with with some people at other companies, is we're not just trying to make an AI agent who can like beat a game. And because in some ways that's easier, right? We want to make it, as you said, like an AI agent who understands language and participates in the game according to like how you discuss it, right? And so that might involve like, you can imagine every now and then, like if you're being silly with your friends, you might like say like, let's deliberately try and get killed or something, right? Like that's not like a, you know, and so it's actually like a much broader set of tasks. And it also means that we really need to understand what the user is saying. And so for that, I would say like the reward signal is harder because in Minecraft, again, we could just focus on winning at Minecraft, like, you know, make the agent able to win the game. But that might be fun to watch once, but it like there, you know, particularly a game like Minecraft is very open-ended. So there's like really many ways you can play. You can not even worry about winning. You can win in different ways. You can
Yeah.
just spend your time building. And so we actually are trying to build an agent that like understands what you're asking, and participates with you, which I think is a broader and harder problem than just like, you know, kind of like race towards the end and win.
Yeah. Yeah, so I see what you're saying now because it is I was thinking like, oh, well, if you're just trying to build something that can win, it feels like that is not that hard of a problem. But now if it's you're trying to build something that can be the teammate that will be goofy or it will mess up or it will understand the plan if you're playing whatever, Rainbow Six or Halo, and you're planning out with friends, like, "You go over there to the left," it knows to go over there,
Right.
and it's not just gonna be like, "No, I've got the better route calculated, and I'm just gonna beat the game
Right,
right now,
right, right.
boom."
Yeah, yeah, and I think particularly because, you know, like, I would say, I mean, it's not always been true, but, you know, some of, like, beating the game can just be, like, faster reaction times, right? So, like, you know, like, I think that's where, again, we don't wanna just beat a game, we wanna, like, be a like, you know, understand the game and what people are asking of us, and play in, like, a human-like style or whatever. So beating the game is one thing. They might say, like, "Show me how fast you can speed run this game," but, yeah, there's many other tasks that people will ask of us, and I think yeah, that is like a broader and harder problem.
Hmm. Well, I know you guys are hiring, so for anybody that thinks that these problems are fun and interesting and they wanna go and work with you, I highly encourage it because this sounds super cool, and it's a distributed team, so you're remote okay, and, yeah, thanks for coming on here, JJ.
No worries. Thanks for your time.